And I was building SciPy, released in 2001, was shepherding it. I had graduate students at BYU working for me, developing further modules in SciPy. And I started at that point talking to the folks at the Hubble Space Telescope who were building additional features. They wanted more that wasn't available on numeric, right? So they realized there was a need to build a better array library. So they had started NumArray. And so NumArray there was numeric and NumArray were emerging. By about 2004. There was kind of two array libraries in the Python ecosystem, both being used. And particularly, there's a library called NDImage. And as a student of medical imaging, NDImage had a morphology image processing system that I was jealous of. Like, oh, I want that in SciPy. It'd be great. I wish I had that tool. And I had it, but it was in NumArray. It was based on NumArray. And at the time, if I loaded my data, I remember I was loading data into numeric arrays early with DICOM format. Great. Now I have it in memory. Oh, but now I need a NumArray version. And so I would have to copy it over to NumArray. And so if you're talking about gigabytes of memory, that's really a non-starter. And so this is a problem. We can't have libraries built on top of different array objects that don't share data in common ways. So that was why NumPy exists, because I saw the problem. There weren't that many people who could do anything about it. I didn't know that I could do anything about it either. I was a professor of electrical and computer engineering focused on electromagnetism and signal processing who used these libraries and knew some C, but I wasn't a creator of languages and type systems. And I understood the SciPy extension capability, the Python extension capability. I knew how to extend Python, but man, taking on something like writing NumPy was challenging, right? And so, but I did. I had a class fall through as a professor. And even though my graduate degree professor, my department chair, when I'd applied for tenure and 2 years earlier, had said, well, we like the progress you're making, but you're kind of doing too much open source stuff. So probably ought to think about, maybe more papers, more fund grants, less open source. So I promptly go and write more open source with NumPy. Again, not because I wanted to, stick it to my department chair, because I just tried to follow where the need was. And I saw this need in the community. I saw this opportunity to do something, and I just felt like someone's got to do this. And you look around, eventually you go, well, who's going to do it? Like, I had already known enough about the community. I was somebody that knew enough. I said, oh, I can try. And it was daunting. It was, and I wished I'd had me now to advise me then, because there's tons of stuff I didn't know. And it's embarrassing because it's in the code now, and it's like the community's just recovering from that, honestly. So, but I guess I say that because, look, desire is important, and you do your best you can, but you're not going to be perfect. And that's what open source can help you with, is actually make it better. And it takes a little bit of it's okay. You don't have to. A lot of young people I meet, they sort of have this impression that the first thing they do has got to be perfect. And it really can stall development. It can really stall doing something. I would say the most important thing is be productive, do things, get things shipped, and then be open to feedback. And the best realization you're doing something valuable is feedback, is getting criticism. Like the worst is apathy. Like, you're not succeeding if nobody cares. Mm-hmm. You are succeeding if you get people criticizing it even. So awesome. This is something that I get feedback. So
yeah, that's a great.
But it's hard emotionally. It's going to be hard emotionally because it is emotional a bit. You put the more effort you put into something, it's your baby. You put it out there. You want people to like it. And what I realized, and people did like what I produced, but not because they were critical technically. In fact, I needed some of that technical criticism because there's, my NumPy. So I wrote NumPy in 2005. Took about another year for it to stabilize, and I presented at the SciPy conference, which we'd started in 2001. So I presented at like the 2006 SciPy conference, and Guido came to that conference, by the way, and he saw me demo NumPy actually, and he saw me demo the type system. And I wished I would have understood at the time what I built was a Python 1 type system in NumPy. I sort of extended the Python 1 version of the type system. Wouldn't be till later that I recognized exactly what Guido had done in Python 2 to integrate 1 style classes with Python 2 style classes. If I had just done that in NumPy, we'd be better off. So I've known that for a long time. Now, finally, NumPy 2.0 is starting to fix that problem. Sebastian, I forget his last name, unfortunately. Sebastian's been great. He's been doing some really good work on the type system in NumPy. And I'm super happy that we have some other people working on NumPy full time, or at least part time, because of Quantsite Labs. So that's what I did. I got NumPy out the door. It did not help my tenure application, despite lots of scientists liking it and appreciating the work to get NumPy. And I knew I'd succeeded with NumPy as soon as Matplotlib made a dependency on NumPy. Right? It was before that making a dependency on numerics, which was kind of letting you pick between the two. I'll say one more thing about NumPy that's really critical, because we fixed it twice. I fixed the immediate problem of, there's two array libraries, let's get one. But then what's the ultimate cause of the problem was a lack of shared data structure. It was a lack of a way to have data that could be shared between arrays. So we created the buffer protocol in Python 2. And that's how I got to know the Python developers better, is I made several contributions to the Python language itself. Some small. The biggest one was the buffer protocol, which is basically a way for like a sequence protocol. Python has these protocols, which properly understood are actually would be better served as meta-type extensions. This is something that I should talk to the Python community about, honestly, because once I understand that, and it took me years to understand this, it wasn't until about 7 years ago that I finally realized, this is how the whole thing could work. But the buffer protocol was a way for things to share data to each other, and we're back to that actually, because when I woke up from my entrepreneurial activities and came back in 2018 to the NumPy world and what had happened and where we are go from here, I look up and I see a dozen array libraries in Python. We solved the problem of unifying them in NumPy in 2005, but really, we didn't have GPU support, we didn't have automatic differentiation, we didn't have a funding model to get those added. And so when that came up in the deep learning spaces, Meta, Microsoft, Google, they spent millions of dollars, a lot of money, basically rebuilding tools. So PyTorch, and also because they came from not Python land, they came from C++ libraries and so forth. I've come to know some of the history of those libraries, where they came from. Deep respect for the developers thereof, but I'm still eager to see cooperative communication, because I think we could save a lot of people, save us a lot of time by just being aware of what's out there. But there's tons of array libraries. And so, we're going to write another one. We didn't do it this time. We actually went and wrote data.apis.org. If you're interested, go to data-apis.org. And that will show you it's a standard we're building, the array standard. Building off of the buffer protocol, which already allowed interoperability between arrays, so they can share the same data. Because at that point, if the interface is a little different, that's fine, as long as you don't have to copy the data back and forth. So anyway, that's the history of where SciPy and NumPy came from. But they've been very important to me to get those, to support the scientific use of Python.
There's a few threads that you mentioned in there that remind me of my interview with Wes McKinney, who created Pandas.
Sure.
So we had him in episode number 523, and he created Pandas because it was a need that he had. Yep. And similar to what you're describing with NumPy, if he could go back in time, he would do it all very differently. And like you, he is doing that. So things like the Apache Arrow project that he now does is to deal with some of the key limitations that are now baked into Pandas. And so, it's interesting to see that kind of parallel journey.
Yeah. So in fact, what I'd love to see, one of the challenges both of us have faced, is that funding for that is not prevalent, right? Like there really isn't a space to go and say, oh, cool, you want to you want to make NumPy better? Cool, here's $1 million. Or here's instead you have to go create a company idea and then try to get funding for that company. And then hopefully some of that money for the company can go back to fund the project. And so, but it's not really solid. Yes, there are now some grants you can get, but grant applications can be challenging because that's a whole other style. Anyway, so there's multiple parallels with Wes, and I've been Wes and I are friends. We've talked for years. He's I like to think that actually the D-type we created that enabled record arrays gave rise to the Pandas movement, because it was kind of like almost a data frame. It kind of hinted at a data frame, and they did. Record arrays gave you this idea of, I've got this cluster of data, they're all together. But the big issue was it was an array of records, right? So it's row based basically. If you think of the orientation, it's row oriented because all the record is together. The NumPy model is you have a big block of multidimensional something, right? But there's a defined something that it is. You can define the number of bytes and so forth. So it's an awesome model for many applications, but having to, you want to add a column, right? You have to insert into the record and then remap everything, right? So it doesn't really make it easy. So, data frames, they're basically structures of arrays. You can imagine a structure with multiple arrays, and that effectively is one of the foundational elements of pandas. Then, of course, the APIs you put on it are a little different. The kinds of processing steps you want to do, the joining the compute you do with the data frames is also a little different. But yes, it's an interesting world to watch. In fact, having written NumPy and then having seen it start to be used, I had a lot of conversations with a lot of people, including Wes, including the R community. Like at one point in 2008, I talked to many leaders of the R community who basically were like, well, could we work together? Maybe we could merge our efforts somehow. Because they were suffering under the strain of a massive user community and very few developers, right? It was a challenge because it's like there's lots of scientists who use stats, but there aren't that many developers who can develop infrastructure for statistical thinking. And we talked about that at length. I think there's things we could have done, but there was no money to support it. Wasn't any big, So one of my desires has been to try to figure out how to get the people with the budgets to talk to the right people, because very often they don't. They end up going and talking to the person nearest them who knows some stuff, but is usually completely unaware of this other activity that's been going on, and they don't pull in the right people. Fortunately, I'm really fortunate that PyTorch and Sumit, who's been leading the PyTorch effort for years at Meta, at Facebook, then Meta, we were able to build a relationship. And I reached out to both the PyTorch and the TensorFlow teams and people in those teams to try to build a relationship to see how do we connect these emerging capabilities with the existing SciPy ecosystem, and had a lot of success with Sumit because of him. We were able to establish some things. And TensorFlow we're still working on. They're great people over there, but they have different. You look at the business infrastructure, and it's part of the reason is because Meta, the Torch was emerging in something called FAIR, which is a research group, whereas TensorFlow was kind of part of the cloud infrastructure. They had to use it internally. And there is actually work to create open source interfaces in a company, to create something that can interface the open source ecosystem and your company. And you have to be intentional about that. And not only intentional, but also, make sure you're doing some good things. So I really like to promote people that are good DevRel people that understand that and try to help work with them. And that's one of I look around at what can I do to help right now? And I'm always looking for where can I help? I like to think I could code, and I can code a little bit, but a lot of people code much faster than I do. Mostly what I really do well is help architect. Like I said, if I could help me younger, I could have really helped me younger. If we could somehow get that time machine loop going.
Yeah, and there would be no harmful consequences to that at all. Everything would work out
No,
perfectly.
of course not. No. We're totally fine.
No. So I really quickly here, I can't remember now. Oh, I think it was talking about how NumPy was distributed, or I can't remember exactly what put me on this.
NumPy wasn't distributed, but it needed GPUs. It didn't have GPU support, nor was it working on more than one node. That was another area. Yeah, that actually leads to the Anaconda story, right?
Yeah.
Those problems there. And so I think it leads into the business stories.
So right before we get to Anaconda, something that I just dug up now again, I can't remember what caused me to do this, but I just thought to myself, how much is NumPy downloaded every day? And do you know offhand? So looking at I can see easily from PyPy. So just from PyPy installs alone. So this doesn't include Anaconda, which we're getting into. It's over 8 million a day.
Yeah, that makes sense. Yeah, now some of those are bots.
Yeah, of course, right? Probably most of it.
I would say most of them, because it's in the build infrastructure, especially recently. What I'd like to see is that if you look at the growth there, we saw some of the things in Anaconda, but it is hard. It actually illustrates one of the challenges of open source is telemetry, or just statistics about usage. Because one of the things I learned later is that people want to fund stuff, but they want to know, well, what am I funding? And that kind of information about who's installing what where could be helpful as people try to understand, okay, where is the energy here? So I joked before, nobody sends Christmas cards, nobody sends postcards. They don't tell you what's happening. You don't. A lot of people, when I was early contributor to open source, many of the old guard, or the people who are older, they were really nervous about getting overwhelmed with support questions. I remember this, like, oh, we can't open source that. I can't handle all the support requests I'll get. I'm like, okay, I hear your point. So that hasn't happened. Like, I would say the opposite has happened, right? I don't get enough support questions, right? And then of course not right now. I'm not at the front lines of NumPy support. So, please don't inundate me with your support questions about NumPy. And if you can have them, and I have a sales team.